Okay, so this last problem that we have sa lecture natin is about the design of doubly reinforced beams. Wherein dito sa problem natin, particularly, meron tayong free design na we need to design the reinforcement details of a 300 by 450 millimeters reinforced concrete beam. Wherein, yung 300 by 450 is already the base and the nominal depth. So in this case, hindi pa natin alam yung effective depth natin. Wherein we are given the following. We have a concrete cover of 60 mm from center of reinforcements, meaning to say, yung 60 millimeters na concrete cover would emanate on both compression and tension. To say of equal spacing ngayon or equal concrete cover yung para doon sa A'(S) and para doon sa AS. So this is AS and this is A'(S). Ngayon, dito sa sa problem natin, we have a present compressive stress of 20.7 megapascals, tensile stress of yield strength of steel of 275 megapascals, moment due to dead load of 120, and moment due to live load of 160. So in this problem, we need to use 28 millimeter diameter bars for our reinforcement. Ngayon, dito sa case natin, alam natin na kapag design yung problem natin, as we have discussed earlier, kapag design, kailangan yung ultimate moment capacity or yung ultimate moment due to applied load must be less than or equal to VMN, which is yung capacity natin. Or we should say na ito yung allowable loading natin. This case is for singly reinforced beams. Pero what if ang ang reinforcement natin ay double? Magiging double lang siya if yung MU is greater than VMN. So kapag greater than, punta tayo sa doubly reinforced beam. Okay. So paano tayo mag-approach dito sa particular problem na to? So ang first na dapat nating malaman is ano ba yung applied load natin. So determining MU, since ang given natin is moment due to dead load and moment due to live load, we need to consider yung factors na involved. Meaning to say, meron tayong 1.2 times dead load plus 1.6 ang live load. Sa case natin, given na yung moment due to dead load and moment due to live load. So therefore, pwede na natin siyang i-direct substitute. So equal to 1.2 multiplied by dead load, which is 120, plus 1.6 multiplied by 160, of which we will arrive at an ultimate moment of how much? So tingnan natin. Upon solving for MU, ang makukuha natin is, pindutin muna natin sa calcu. We have 400 kilonewtons. 400 kilonewton meter of ultimate moment na kailangan natin i-resist. Now, dito sa problem na to, we have two approaches. Sa two approaches, pwede natin gawin yung either of the two. Either solve for raw actual or i-solve natin na singly reinforced yung beam natin with raw maximum as reinforcement. Ngayon, ipakita natin yung dalawang methods para kahit paano makita natin kung ano ba yung difference. Now, kung yung raw actual yung kukunin natin, in what way natin siya hahanapin? Ngayon, the same pa rin na singly reinforced beam yung i-assume natin na condition. Kasi hindi pa natin alam kung singly or doubly yung beam natin. So ngayon, i-consider natin as if singly reinforced yung concrete beam natin. Na sure na hindi pa natin alam kung ano ba yung value ng AX. Same time, hindi pa natin alam kung ano ba yung magiging actual value ng neutral axis natin or yung mga corresponding distances. Since wala pa tayong idea kung ano yung bakal natin. Meron tayong compression and tension. Ngayon, yung raw actual na to, na sinasabi natin is due to MU. So, ibig sabihin, kailangan natin equate yung MU doon sa pagkuha ng raw actual. So, paano ulit natin kinukuha yon? Alam natin na yung compression is equal to 0.85 F prime C AB. And then yung tension natin is equal to AS Fy. Yung compression is equal to tension, hindi pa natin pwedeng gamitin yan. Since hindi pa natin alam kung ano ba yung tension, since wala tayong AS and wala tayong compression, since hindi natin alam yung value ng A. So, pwede tayong maghanap ng approach doon sa nominal moment capacity or yung phi Mn, which is the ultimate moment capacity na ng beam. Wherein may moment arm tayo na D minus A over 2 na hindi pa natin alam. Although alam natin na yung MU is equal to phi Mn, meron pa tayong other way para makuha yung ultimate moment na ibang way ang gagamitin natin. Yung raw actual. MU is equal to phi Mn or equal to the design ratio multiplied by BD squared. Wherein, alam natin na yung R is equal to raw actual multiplied by Fy multiplied by 1 minus raw actual Fy all over 1.7 F prime C. Of which may kulang pa tayo dito sa value ng R since hindi nominal ang hinahanap natin. So therefore, meron pang isang term dyan. Ang isang term dyan for R again is equal to phi. Diba? So, makukuha natin na yung design ratio is nasa ultimate na state. So, R is equal to raw actual Fy multiplied by 1 minus raw actual Fy all over 1.7 F prime C. Ngayon, dito sa dito sa case natin, since meron na tayong value ng R na pwedeng kuhanin from the ultimate moment na 400 kilonewton meter earlier. So dito sa case natin, yung 400, pwede na nating i-equate. Since alam natin na yung ultimate moment is equal to phi or is equal to RBD squared. So meron tayong 400 times 10 raised to 6 is equal to R multiplied by BD squared. Yung B natin or yung base natin is equal to 300 mm. And yung effective depth natin ay hindi pa natin nakakompute kanina. So ang effective depth natin in this case is 450 minus 60 or 390 mm. Yan ngayon yung effective depth natin. So multiplied by 390 squared. Therefore, the value of R is equal to Ilan ngayon? So we need to compute. Meron tayong 400 times 10 raised to 6 na i-divide natin sa 300 by 390 squared. 300 times 390 squared. So 400 times 10 raised to 6 divided by, answer is, meron tayong 8.766 megapascals na design ratio. Ngayon, sir, hindi ko alam kung ano yung value ng phi. Given na wala naman tayong tinitingnan kung yielding or not yung reinforcement kasi wala naman tayong basis. So, instead na, since this is a design problem, we need to take in consideration that ideally, design should be tension controlled. So therefore, yung strength reduction factor natin is equal to 0.9 and yung raw actual na or yung raw maximum natin rather is equal to 3 over 8 multiplied by 0.85 f prime c beta 1 all over fy. So, ibig sabihin, pwede na natin makuha yung value ng raw actual since meron tayong value ng phi na equal to 0.9. So, ibig sabihin, yung 8.766 natin is now equal to 0.9 multiplied by raw actual multiplied by fy na equal to, ang yield strength natin ay 275 multiplied by 1 minus raw actual. Teka lang, ibahin natin yung grouping symbol. Baka sabihin, hindi ako marunong mag-grouping symbol. Oh my God. Tingnan natin ulit. Nalilimutan ko talaga magpalit ng color kapag nag-erase. So, balik natin. Meron tayong 1 minus the quantity of raw actual times fy ulit natin na 275 all over, or sorry, raw actual times fy, yeah, 275 all over 1.7 multiplied by f prime c natin na equal to 20.7. Ngayon, upon solving this, kailangan nating i-simplify ito kasi alam natin na magiging quadratic yung equation natin. Since magiging quadratic yung equation natin, we need to at least tingnan kung ano yung magiging values nila. Kasi yung quadratic formula ngayon, yung magiging basis natin para doon sa mga limits natin. Pero syempre, before natin kuhanin to, maganda na makuha natin yung raw maximum para kahit paano may limits tayo. Pero kung hindi naman kayo mag-shift solve, hindi naman din kailangan. Diba? So, tingnan muna natin. Tinatry ko sa calculator ngayon kung pwede yung shift solve using an assumed value of raw maximum. So, tinitingnan ko muna. Ayan. So, medyo matagal calculator ko. So, itry na natin na mag-quadratic equation na lang. So, yung 8.766 ulit is i-simplify natin. So, 0.9 times 275 is equal to 247.5 raw actual multiplied by 1 minus, so isimplify din natin itong nasa loob. So meron tayong raw actual times 275. So 275 natin, i-divide natin ng 1.7 by 20.7. So meron tayong 1 minus 7.814 raw actual. Ngayon, kung meron tayong 7.814 na raw actual, pwede na natin i-distribute din yan at the same time. So meron tayong 8.766 is equal to 247.5 raw actual minus yung term natin na gagamitin para dyan sa value ng raw. So meron tayong, check natin. So 247.5 times 7.814 is 1933.965. Raw actual squared. Since kita natin at some point na yung raw actual natin should be distributed. Ngayon, we can simplify yung equation na we have 1933.965 raw actual squared minus 247.5 raw actual plus 8.766 is equal to 0. Wherein, kung quadratic equation na titingnan natin, yung x natin is equal to negative b plus or minus yung quantity ng b squared is 4ac all over 2a. Wherein, yung a natin ngayon is equal to 1933.965, b is equal to negative 247.5, and c is equal to 8.766. So yung x1 natin and x2 ay equal to 9. So kung meron kayo sa calculator ng mode 5, 3, mas madali. Pero kung wala, mag-quadratic formula ka. So meron tayong 1933.965 and then negative 247.5. And then meron tayong 8.766. Sa case natin, so dito sa nakuha ko, meron tayong imaginary na number. So meaning to say may mali ako doon sa equation natin. Ngayon, dito sa mali ko sa equation, siguro i-check ko muna nga kung saan ako possibly nagkamali. Tama naman yung derivation ko sa R. R is equal to raw actual times P times Fy multiplied by 1 minus raw actual Fy all over 1.7 F prime C. Which is correct. Ngayon, yung design natin should be tension controlled or 0.9. 8.766 naman din yung nakuha ko. So, tingnan nga natin ulit. Tingnan natin itong quadratic equation ng consider natin. C. Meron tayong negative b. So, okay. Hindi impossible na magkaroon ng ano. Teka lang titingnan ko muna yung calculator natin. Inisip ko talaga kung saan ako nagkamali. Hindi ko matanggap na may imaginary. Hindi siya maganda sa mata. Ayun, sabi na may mali ako. This is not plus for AC, but this is minus. Pero dahil ang ginamit ko ay calculator na function, na ano ko sa quadratic formula. So negative b plus or minus b squared minus 4ac. Ayun, ngayon ko na nakita ko sa ano ko, kung saan magkakaroon ng discrepancy. Kung mapapansin nyo, yung value ng yung negative 4ac is both positive, yung 8, saka yung c. So meaning to say, yung answer natin would arrive to really an imaginary function. Kaya ngayon, tingnan natin, gusto ko talagang i-justify itong process na to eh. Nag-iisip ako ng way kung paano ma-justify. Since ayoko ng maging fail itong itong particular example natin. Pero kasi hindi siya mag-error dapat eh. So, try natin ng quadratic formula. So, negative b, so meron tayong 247.5 plus or minus square root ng b squared. So, 247.5 squared minus 4ac. 4 multiplied by a na 1933.965. And yung c na 8.766. All over 2 multiplied by a na 1933.965. Ayun nga. So, nagma-math error. So, may imaginary doon sa doon sa equation natin. Since yung minus 4ac is higher than b squared. Ngayon, dito sa natin, i-cut natin tong itong process na to. So, since medyo mahaba yung ruta, kung mapapansin nyo, kung medyo mahaba yung process natin, kung mag-lean tayo dito sa raw actual, so pwede natin gawin na another option is yung singly reinforced beam with raw maximum as reinforcement. Since ang ideal natin na design should be tension controlled, kailangan yung raw maximum natin would be used as this one. So, to prove, meron tayong singly reinforced beam with raw maximum as reinforcement. Kailangan mag-arrive tayo na yung ultimate moment natin is less than or equal to the moment capacity due to the singly reinforced beam with raw maximum as reinforcement. So, since ang assumed condition natin is tension control yung beam natin, therefore, yung value ng phi is equal to 0.9 and yung raw maximum ulit is equal to 3 over 8 multiplied by 0.85 f prime c beta 1 all over Fy. So ito nga pala guys, itong math kanina na dito sa case natin, please try to solve this one. If may nakita kayo na probable error ko, kindly inform me para at least may justice dito sa ano natin. May justice dito sa ginawa natin. Ngayon, since meron tayong another way, so try natin i-solve ngayon to. Yung raw maximum now is equal to 3/8 multiplied by 0.85 times f prime c na 20.7 times beta 1. Yung beta 1 natin, since ang f prime c is equal to 20.7, beta 1 is equal to 0.85 since f prime c is less than 28. Ngayon, yung 0.85 times 20.7 times 0.85 ulit, all over Fy, wherein our value of Fy is 275. Raw maximum now is equal to, yun natin, meron tayong 3/8 multiplied by 0.85 and 20.7 and 0.85 all over 275. Meron tayong 0.0204. So, ibig sabihin, yung AS natin is equal to raw maximum multiplied by BD. So, meron tayong 0.0204 multiplied by yung base natin na 300 and yung D natin na 390. AS na gagamitin natin for trial is equal to times 300 times 390. Meron tayong 2386.8 square millimeters. So, since meron na tayong value ng AS, we can now proceed with checking if correct yung assumption natin. So, meron tayong AS, since ina-assume pa natin na this is singly reinforced, pwede tayong mag-check between compression and tension. Yung compression natin is equal to 0.85 F prime C AG, whereas yung tension natin is equal to AS Fy. Meron na tayong value for AS earlier, which is equal to 2,386.8 square millimeters multiplied by Fy natin na 275. Tension is equal to meron tayong 656,370. So yung compression natin, since kailangan natin i-simplify ito, meron tayong 0.85 multiplied by 20.7 times 8 and yung base natin na 300. Compression is equal to 5278.5. Okay. Importante na makuha natin yung A because alam natin na yung ultimate moment natin is equal to Vmn or kung singly yung case natin, yung value ng Z is dependent doon sa value ng A. Kasi, alam natin na this is phi multiplied by either C or T multiplied by D minus A over 2. Ayan. So we need to find the value of A. So meron tayong 5278.5A is equal to 656,370. Wherein value of A is now equal to 124.347. Millimeters. Is there a need to find the value of C? So, kung may need para hanapin yung value ng C, this time hindi. Hindi pa natin siya kailangang hanapin kasi hindi pa naman natin alam kung tama ba yung assumption natin. Kailangan lang natin yung value ng C kung alam na natin na singly or doubly yung beam natin. So, ano nga ba yung gagawin nating basis ulit? Yung basis natin for singly or doubly is yung MU dapat should be less than or equal to phi MN para sa singly reinforced beam. So, enough lang tayo dito sa A. Kasi meron na tayong MU na applied and ang hinahanap na lang natin is yung VMN na allowable. So, assuming for the value of A to be 124.347, we can now solve for VMN. So, VMN is equal to 0.9 since this is tension controlled multiplied by 656,370, which is from the tensile force, multiplied by D, the 390, minus A over 2, which is 124.347 all over 2. VMN now is equal to 0.9 times 656,370 multiplied by 390 minus 124.347 divided by 2. So ang VMN natin is 193,657,931.8 Newton mm. Or meron tayong 193.658 kilonewton meter. Ngayon, ano yung po pwede natin ma-prove? Alam natin na yung MU is equal to 400. So yung 400 kilonewton meter is greater than 193.658 kilonewton meter na galing sa maximum. So this is the allowable. Then this is greater than, or sorry, hindi ito yung allowable, ito yung applied. Yung applied natin is greater than the allowable. Therefore, yung reinforcement natin is doubly. So, ibig sabihin, maghahanap pa rin tayo ng another value for A. Since alam natin na doubly reinforced yung beam natin. Ngayon, how does this work? Kung alam natin na doubly reinforced yung beam natin, and alam natin na 400 kilonewton meter yung dapat natin na target, or greater than 400 kilonewton meter dapat yung capacity ng beam. Ngayon, i-consider natin as if ang allowable natin ay yung 400 kilonewton meter. So meron tayong 60. Ano ulit itong 60 na to? Ang 60 mm na to, yung D prime or yung conflict cover natin kanina. Tapos, ito ngayon na effective depth na 390. Then, hindi natin alam kung ano ba yung total na AX. And hindi pa natin alam kung ano yung A prime S. Pero, magkakaroon tayo ng idea ngayon kung ano ba yung dapat gawin dyan. Kanina, kung mapapansin niyo, yung ginamit natin na tension due to singly reinforced beam ay hindi pala enough para ma-resist yung 400 kN. So, ibig sabihin, dito sa system natin, dapat 400 kN yung total natin. So, kanina, may nasolve tayo na 193.658 na allowable. Yung 193.568 na allowable dito is yung galing doon sa nominal moment na ang assumed value ng A is 124.347. Ngayon, itong 193.658 na to is galing doon sa singly reinforced beam na kailangan niya ng assistance. Since meron na tayong assumed value ng rho maximum, why not gawin na lang natin siyang way para makuha yung possible excess na nandito sa A'(S). Since hindi pa natin alam dito sa system natin kung ano ba yung compression ng steel. Although yung compression ng concrete, may idea na tayo dapat dyan at some point. So yung T1 and T2 ay meron na tayong or wala pa tayong assumed value for both T1 and T2. Ngayon, given na meron tayong dalawang nominal moments, in what way natin siya pwedeng approach? Ngayon, yung 400 kilonewton meter is, simply put, pwede nating i-consider ngayon itong buong system na to as yung 193.658. Kasi, ito ngayong T1 na to is considered as, or yung MN1 na to, PMN1, is considered as yung galing sa SRB or yung galing doon sa singly reinforced beam natin. So, yung nominal moment na makukuha natin dito, which is PMN2, is yung galing sa compression ng steel. So, ibig sabihin yung 400 or yung MU natin is equal to P MN1 plus P MN2. Simply put, yung 193.658 ay lacking pa rin ng Phi MN2 para mag-equate siya sa 400. Ibig sabihin, yung Phi MN2 natin is just equal to 400 minus 193.658. So, Phi MN2 is now equal to 206.342. Kilonewton meter. Take note that this is Phi MN2. Therefore, yung MN2 natin is just 206.342 divided by 0.9 since we consider this as tension controlled, or equal to 229.269 kilonewton meter. So, tingnan muna natin kung saan ba po pwede natin gamitin itong dalawang nominal moment. So, ngayon, kung meron tayong value ng mn2 na nakuha, at some point, pwede na nating makuha yung value ng a prime s. Knowing that kung babalik natin dito, ang compression ng steel natin is equal to a prime s fy and T2 is equal to AS2 F1. Ngayon, dito sa case natin po pwede nating kuhanin ngayon yan. Alam natin na yung phi mn2 is equal to phi multiplied by either compression ng steel this time or T2 multiplied by Fy or sorry, hindi Fy, multiplied by D minus D prime, which is yung moment arc. Diba? Alam natin na yung 60 is D prime, so this particular value na Z2 is equal to D minus D prime. Ayan, yung mn2 natin, kung ayaw nyo na ng phi, pwede rin naman natin gawin na yung mn2 is just equal to compression ng steel or T2 multiplied by D minus D prime. Ngayon, so either of the two, pwede nating hanapin. Yung in this particular case, pwede nating sabihin na yung 229.269 times 10 raised to 6 is equal to either yung CS or T2. So, ibig sabihin, kung either CS or T2, pwede natin sabihin na yung A prime S is also equal to AS2. Mas madali na kuhanin na lang natin yung value ng A prime S. Diba? So, meron tayong A prime S Fy, wherein yung Fy natin is equal to 275 multiplied by D na 390 minus B prime na 60. So, in this case, A prime S is equal to, so 229.269 times 10 raised to 6 divided by 275 multiplied by 395 minus 60. Ang A prime S natin is equal to 2488.673 square millimeters. Ngayon, if we have to use 28 mm diameter para doon sa assumed value ng A prime S, yung area ng bar natin is equal to pi over 4 times 28 squared or equal to, tingnan natin. Meron tayong 615.752 square millimeters. So, ibig sabihin, yung number ng bars natin in terms of compression is now equal to, so meron tayong 2488.673 all over 615.752. So doon sa handouts mo na din. So ngayon, ang nakuha nating number of bars is equal to 4.042. Let us consider this as 5 28 mm diameter. Kasi yung 0.042 is considered as 1. Hindi ka pwede mag-round down kapag reinforcement details ang tinitingnan mo ngayon. Check natin. So, yung ano natin, dito sa case natin, since meron tayong 5 28 mm diameters for the top bar, paano naman natin ngayon isosolve yung bottom bar? So, yung bottom bar natin na AS, meron tayong na-solve earlier. Kung maaalala ninyo, yung AS natin, so yung total AS dapat natin should be AS1 plus AS2. Taking note ulit na yung AS1 manggagaling sa singly reinforced beam with rho maximum as reinforcement plus yung AS2 na mula doon sa compression ng steel. Meaning to say, yung AS1 na na-solve natin kanina due to the maximum value of reinforcement, this one should be added doon sa isa pa. So meron tayong 2386.8 plus yung 2488. Therefore, yung AS natin na total is now equal to 2386.8 plus 2488.673 or meron tayong 4875.473 square millimeters. So sa AS natin, yung number of bars now would be equal to 4875.473 divided by 615.752. Meron tayong 7.917 or meron tayong 8 na 28 mm diameter bars. Ngayon, in this case, kailangan natin alamin kung ano ba yung situation ng reinforcement natin. Kailangan natin tingnan kung yielding ba or not yielding yung reinforcement natin. So, yung Fs and F prime S, kailangan natin alamin. Now, for the assumed value of C, kailangan natin alamin na yung A is equal to beta 1 C. Therefore, yung C is meron tayong value ng A kanina. Ang value ng A natin is 124.347. All over beta 1, which is equal to 0.85. So, meron tayong 146.290. 291 millimeters. Sir, question, bakit hindi na tayo nag-solve ng panibagong value ng A? Di ba po mali yung assumption natin na singly? Okay. Kung analysis yung case natin, definitely, ganun yung magiging approach natin. Pero since this is a design problem, hindi natin alam exactly kung ano ba yung mga reinforcements na involved. So, ibig sabihin, from a standpoint na yung singly reinforced beam due to the maximum reinforcement, yung po pwede nating initial strength ng concrete beam natin, po pwede tayong mag-compensate ng compression mula doon sa compression na initially ng concrete. Kumbaga yung capacity natin ng moment is hindi na-attain yung in-apply na load. So therefore, magko-compensate tayo doon sa compressive reinforcement, which we found out na yung 400 kilonewton meter is hindi pala enough yung 193 to resist. So therefore, magko-compensate tayo mula doon sa VMN2. Okay? Ngayon, for the value of C, meron tayong 146.291. Therefore, in this case, pwede nating makuha ngayon yung value ng F prime S and Fs. Wherein F prime S is equal to 600 multiplied by C minus D prime all over C. And yung Fs natin is equal to 600 multiplied by D minus C all over C. F prime S natin, so meron tayong 600 multiplied by 146.291 all over 146.291. So, sorry. Meron pa palang minus. Meron tayong minus D prime, which is 60. All over 146.291. Wherein F prime S is equal to, tingnan natin. 600. So meron tayong 353.915 mega Pascal. So yung F prime S natin is greater than Fy, therefore, yield D. So next, yung Fs natin. Meron tayong 600 multiplied by the effective depth na 390 minus 146.291 all over 146.291. Equating this, we have we have 999.552 mega Pascal. So yung Fs natin is greater than Fy. Therefore, this is also yield D. Ngayon, kung titingnan natin yung case natin, ano yung makikita ninyong assumption? Ngayon, dito sa ano natin, initially, nag-assume tayo na this is tension control. Kung mapapansin nyo na 999.552 yung lumabas. I-consider pa ba natin na this is in transition? Hindi na. Kasi yung 999.552, pwede na natin sabihin na this is already 1,000. Kasi, initially nung nag-design tayo, ang ideal condition natin is tension control. So approximately, since marami tayong ginawang, let's say, marami tayong ginawang rounding off. So sa dami ng pag-round off natin, ang nangyari is nagkaroon ng discrepancy na in terms of 0.552. So hindi na natin dapat gawin na magsasolve pa tayo ng iteration for transition. Okay? Ngayon, after natin makuha na yielding yung dalawang reinforcement natin, i-check na natin ngayon if safe yung beam natin. So, paano natin ngayon ma-check kung safe yung reinforcement natin? So, doon sa beam natin kanina, nakakuha tayo ng value ng AS and A'S. Wherein yung A'S daw natin is 528 mm diameter bars rather, and yung AS natin is meron tayong 828 mm diameter. Ngayon, saan natin gagawin to? Kung titingnan natin na safe yan, kailangan yung 400 kilonewton meter natin na ultimate moment capacity should be less than or equal to Pmn1 plus Pmn2. In this case, pwede natin ngayong tingnan kung ano na yung magiging internal moment capacity. Meron tayong compression and meron tayong tension na T1 and compression due to concrete. Then meron tayong compression due to steel and T2. Ngayon, yung compression ng concrete will still remain the same as 0.85 F prime C AB. Or, meron na tayong 0.85 multiplied by 20.7 multiplied by A na nakuha natin earlier na 124.347 multiplied by the base of 300 millimeters. Meron tayong meron tayong 656,365.63 or 64. Pero, kung mapapansin ninyo, medyo skeptical tayo na gamitin yung compression ng concrete because yung T1 and T2 nagkaroon ng change. Yung compression ng steel is nag-iba. Kung mapapansin niyo, yung 5 na 28 and yung 8 na 28 nagbago since medyo malaki yung naging improvement in terms of area. Ngayon, tingnan natin. So, yung A'S natin is equal to 5 times pi over 4 times 28 squared or equal to 3078.761 square millimeters. Ito ngayon yung bagong A'S. Kasi kanina, ang A'S natin is 2488.673. So yung A'S na to is greater doon sa 2488.673. Ito ngayon yung old na A'S. Ibig sabihin din, yung AS natin is nag-iba. Since meron tayong 8 multiplied by pi over 4 times 28 squared. A prime, AS this time is, meron tayong 4926.017 square millimeters. Ngayon, since meron tayong A prime S and AS, pwede natin sabihin na yung AS1 is equal to 4926. Sige, kung ano, para hindi malito, yung equation na lang. AS1 is equal to AS minus A prime S. Since alam natin na yung A prime S is equal to AS2. So meron tayong 4926.017 minus 3078.761. Therefore, yung AS1 natin is equal to 1847.256 square millimeters. Question, sir, kailangan ko pa po bang i-convert ng 28 mm itong bakal na to? Hindi na. Kasi kung mapapansin nyo, yung AS1 natin is just 3 28 mm diameter bars, di ba? Kasi 5 diameter, 5 na 28 diameter, ay kumbaga meron tayong 8 na 28 diameters minus 5 na 28 mm diameter. So 3 28 mm diameters is approximately 1847.256. Ngayon, yung phi mn natin ulit is equal to phi mn1 plus phi mn2. Primarily, this is due to T1 plus due to T2. Pero syempre, yung moment arm natin is iba na ngayon. So this is D minus A over 2 plus P times T2 multiplied by D minus D prime. So, equating, meron tayong 0.9 multiplied by T1. Yung T1 natin is 1847.256 multiplied by 275 multiplied by 390 minus A over 2. Ang value ng A natin kanina is 124.347. Plus yung due to T2. Sir, bakit sa analysis hindi importante yung T1 and T2? Hindi importante sa analysis yung T1 and T2 because present na yung bakal. Ang kailangan lang natin hanapin doon sa analysis sa problem is ano ba yung moment capacity kung ganito yung amount of reinforcement na nag-a-act doon sa beam natin. Okay. So T2, meron tayong 5 28 mm. So meron tayong 3078.761 multiplied by 275 multiplied by 390 minus 60. So yung phi mn natin na total is now equal to 0.9 times. So doon sa first natin, meron tayong, alisin muna natin to. Sa first term natin, meron tayong 149,8809,18.6 plus plus 251,457,804.7. So yung VMN natin is now equal to ang VMN natin is 401,338,723.3 Newton mm. Or meron tayong 401.339 kilonewton meter. Which comes to show that yung mu natin is greater than, is less than Pmn. So yung 400 natin is less doon sa 401.339. Therefore, adequate ngayon yung bin natin. Ibig sabihin, for our final answer, we need to use limang 28 mm diameter top bars and 8 28 mm diameter bottom bars. Yan ngayon yung final answer natin for this particular problem. Okay. So, doon sa module, may nakita akong mali ko na i-revise natin. So, yung mali ko doon sa module is hindi ko divide yung mn2 ng feet. So, ang nagamit ko doon sa module is still yung 206. Pero ang correct dapat should be 229.269. Okay? So, yung mga tanong is please maki-message through your class mayors and I'll be answering those in our usual working time. Okay? So, kung wala nang tanong, or sorry, nasanay ako na synchronous. So, let's end this video na hopefully makapagtanong kayo through your class mayors. So, I will be sending this slide then for your reference. Thank you and ingat lagi.